Okay, another projectile problem. We're going to look at the supply plane needs to drop a package of food to scientists working on a glacier in Greenland. It's interesting. The plane flies 100 meters above the glacier at a speed of 150 meters per second. How far short of the target should it drop the package? All right, so that's a lot going on, but it seems like it's going to be a fun picture to draw. So let's draw our airplane. Let's its wings. Okay, and it's going to drop a package that's got to land on a glacier. What does a glacier look like? Looks like this, let's say. Like an island. All right, so it's going to drop this package right out, and the plane has some horizontal velocity at 115 meters per second. So that's v0x. And the package is going to have that same velocity that the plane has, right? So when it drops out, it actually is moving with the plane at 100 meters per second, 150 meters per second. So my initial velocity of the package is going to go that way. And so it's just going to follow a parabolic path down to the island. Okay, and let's just say, for not to complicate, my island is a little bit too high, but we're just going to say that it's going to a height of 0. Okay, so this is where it's launched. This is where it lands. Let's say wherever the island is, and we want to know how far that should be. Okay, and we know we're going to set up a coordinate axis. This one plus x, this is my plus y. And then let's make a list of what we're given and what we need to find. Okay, yes, I'm going to say that's my origin right there. So my givens, picture took up so much room that time. So in the x direction, and sometimes I just do a t here. So I have x initial, x final, v0x, ax. And I know, a lot of times we're crossing out ax, but you could have a problem where that's not 0, right? If it's not just a free fall problem. y0, y final, v0y, ay. Okay, so the way I set up my coordinate axis, my initial x position is 0. I don't know what x final is. I want to solve for that. My initial velocity in the x direction is 150 meters per second, and my acceleration is 0. Okay, my y, I do know what that y is, right? Wasn't that 100 meters? 100 meters, yep. Okay. So this is 100 meters. So y initial is 100 meters, y final is going to be 0. The initial velocity in the y direction is 0, and my acceleration is 9.8 meters per second squared. Okay, so if you don't know where to start, a good first step is just to write down the equations of motion for the x and y direction. So x final is x initial plus v0 xt plus 1/2 axt squared. Okay, and then we can look at y as well. Y final is y initial plus v0 yt plus 1/2 ayt squared. And let's get rid of everything that we know is 0. So my acceleration in the x direction is 0, so this whole term goes to 0. My initial x is 0, so I'm going to get rid of that. So here I get x final is v0x times t. This is what we're trying to find. Oh my goodness, I forgot to put that down. Find x final. Or you could say it's delta x, but I'm just saying x initial is 0, so I just need to know what x final is. Okay, all right, so that's what I want to find. I know my initial velocity and I don't know t, but my y equation can help me with time. So let's get rid of what we don't, everything is 0 here. So y final will be 0. My initial y velocity is 0, which always makes life easier. Okay, and for here I want to solve for time. So I can subtract y0 from both sides. Doing my algebra first. I multiply 2 and divide by ay minus 2 y0 over ay. Equals t squared. And now I take the square root of both sides. And I get t equals the square root of minus 2 y0 over ay. Now, we could solve for that right now, or we could just keep going with our algebra because algebra is so much fun. And I could just say x final is v0x and take my time term here and plug it in. Square root of minus 2 y0 over ay. And now I just have one equation to plug into. So 150 meters per second is my horizontal velocity. And then I get the square root of 2, sorry, minus 2, don't lose that. Y0 is 100 meters. Gravity is minus 9.8 meters per second squared. And let's plug into Python. So I have 150 times square root. We'll be fine to do this on a calculator, of course. I just don't happen to know where mine is right now. It's 9.8. And I get, well, x final equals 677 meters. And let's just make sure I got that right? So in here I have a meters divided by a meters. So I have 1 divided by 1 over second squared, and that equals second squared. And then I take the square root, and that gives me a second. So I get meters per second here, times seconds, and I'm left with meters. So that is good. If you did solve for that separately, which I think I did over here, then you're getting the time is 4.5. 18. Let's say we'll carry it out so we end up getting the same answer. All right, another projectile problem in the bag.